You guys have been handed out a vocabulary list. And some of the terms that are on that are resistance, voltage, and current. I'll be explaining some of the meanings and theories behind those different terms. We'll just read them off to start with. Resistance, as is stated on the vocabulary list, is a measure of the opposition to current flow in an electrical circuit. Voltage is also called electromotive force. It's a quantitative expression of the potential difference in charge between 2 points in an electrical field. It's the amount of charge in between 2 points. Current is the electrons in motion along a path. That's where we're going to start at. We're going to start with current. Current is the flow of electrons or the movement of electrons along a path. Well, how does that even happen? Everything is comprised of atoms. Everything that we see, touch, feel, everything is comprised of atoms. And inside these atoms, let me get a couple of markers ready to go here. There we go. If you can remember back to science in high school, when you studied an atom is comprised of three things: protons, neutrons, and electrons. The protons and neutrons are in the center, in the nucleus of an atom itself. So we'll just drop some protons and we'll drop some neutrons. Protons have a positive charge, neutrons have a neutral charge, and they're all clustered in the center of a nucleus. And then on the outside of the atom, we have electrons. Electrons are orbiting in different rings around the nucleus of an atom, and they'll be moving around here, and depending on what substance it actually is, it's dictated by how many protons, neutrons, and electrons are comprised that atom. As we start going further away from the nucleus, the attraction of the electrons to the center become less. There's less pull towards the center of that. And as we get on the outside ring of an atom, remember, every atom is different. Gold is different, copper is different, silver is different. All of the different molecules are all different. All the different atoms are different. Gold is an excellent conductor of electrons, of electricity. It's because they have so many bands on it, so many electrons orbiting around the nucleus, that the outside band of this, and the outside band of an atom is called the valence ring. The attraction to the center in that gold is so weak that it's easy for one electron to move over to another one, to another atom. Gold's a little expensive to use as a conductor though. Copper is a good one too. Copper is a great conductor. And that's what's used mostly in our world. In electronics and electricity, we use copper. There's one atom, or one electron in the valence ring of copper. Very little attraction to the center of this thing. So if we have another atom stuck over here, and you remember, an atom, to be a particular substance, has to have a set number of electrons, protons, and neutrons. So if we draw up another one, and don't count how many red circles and purple circles and black circles I have over here, because it probably won't be the same, but just for this lecture, just imagine that all of these, we have the same number. There's a nucleus, we have the rings around the nucleus. This outside ring is the valence ring, and we have one electron out here, barely being conducted by our very little attraction to the center of this thing. And if for some reason we lose that atom, there's going to create a hole right there, isn't it? It's not going to be fulfill the requirements of being that atom. So this atom will attract another, or this, excuse me, this electron, or this atom will attract another electron to fill that void. Can you see where this is going? If we have something that pulls an electron from the valence ring of one atom to another atom to another atom, we start that electron flow. We start current flow. And that's how it's done. One atom will pull the electron out of the valence ring from the atom before it and pull it over. So if there was another atom over here, an atom of copper, and this is what we're depicting up here, if there was a hole, if there was an electron missing in this valence ring, it would actually attract another electron from another atom. So we start seeing that flow of electrons from one atom to another. Now, since we know that part, let's do something else. Let's do this. Let's draw a battery. Y'all know what batteries are. It's things that powers your Walkmans and your VCRs. Got a little post up here. We don't have one down here. And inside of this battery, there's a barrier in between it. Somewhere in the center of this battery, we have a barrier. On one side, on the positive side, we have a total abundance of protons. We got all these protons over here, and they're packed full of it. And there is an abundance of them. There's a huge multitude of protons over here. Bunch of them, like many. Okay, I'm almost finished, hang on. On the other side of this battery, we have a total abundance of electrons, negatively charged particles. It's full of them. This is going to be a lot quicker to draw. So they're just all scattered in here. And unlike polarities attract each other, unlike charges attract each other, but we have this barrier inside here to keep all of these negative particles from going over into the positive side. Remember, I told you on that atom that the electron, the negatively charged particle inside of that atom, went from one atom to another atom, and it flowed and it kept sucking them over. But when we have a battery and it's just standing here and there is no path for these electrons to move over to the positively charged area, they won't move, they're just there. When we complete that path, and remember in the definitions it says current, electrons in motion along a path. If we connected some path for these electrons to flow, to move